All right, well, hello, Honors Algebra 2. This is the second lesson this week in Unit 11. Today we're going to be talking about probability rules. So, to talk about probability rules, first thing we need to talk about is sample space. So, a sample space is the set of all possible outcomes for an experiment. So, to give you an example of this, imagine that you're going to flip a coin twice, which we'd already seen, I believe, in the previous section. But if you think about it, there are going to be four possible outcomes, which are that you could get heads and heads, heads and tails, tails and then heads, and tails and tails. Notice that when we write out a sample space, we use the curled brackets. It's also convention to write s is equal to in front of that to say that your space s is equal to, and then to list out those values. The second thing to talk about is a probability model. So a probability model is a function, oftentimes a table, that gives the probability of each possible value of a random variable. Which, in just a moment, we'll look at an example of what that looks like. Lastly is an event. So an event is a collection of one or more outcomes in a probability experiment. So an event is just what are you trying to find the probability of? Are you trying to find the probability of two heads? Are you trying to find the probability of one heads? And so on. So to look at an example of kind of all of this in context, imagine that we're going to flip a fair coin 3 times. Let's describe the probability model for this chance process and then use it to find the probability of getting at least one heads in 3 flips. Okay, so thinking about flipping a fair coin 3 times, let's think about what our possible outcomes are. Obviously, you've got where you get all heads. You've also got where you've got all tails. So heads, 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 tails, tails, tails. I suppose there's also where you've got heads, heads, and then tails. And then thinking about the other ways that you can get 2 heads, you've got heads, tails, heads, and then you've got heads, heads, tails. All right. Let's think about just getting one head now. So we've got heads, tails, tails. You could also do tails, heads, tails. You could also probably do, let's see, tails, tails, heads we haven't had yet. And I think that's it. And so then the last one was just tails, tails, tails. Okay, so let's make a probability model now. And we're interested in heads, so let's do it in terms of that. So let's describe our different events. We could get 3 heads, we could get 2 heads, we could get 1 heads, or we could get no heads. All right, and so then there are our possible outcomes. We now just need to find the probability of those. So looking at our total number of outcomes, over here there were 8 total outcomes that we've got. Out of those 8, only one of those was where you had 3 heads, so the probability of getting 3 heads is 1 out of 8. For getting 2 heads, there were 3 different ways that you could have that happen, so that would be 3 out of 8. For 1 heads, that was also 3 out of 8. And for no heads, that was just 1 out of 8. That was where there were just 3 tails. So then we want, what is the probability of getting at least 1 head in 3 flips? So we want, what is the probability that we get at least greater than or equal to 1 heads? So really, if you think about that, what that would represent in our table, that would represent at least 1 heads, these 3 columns right here. And so if you add those together, 1 plus 3 plus 3 out of 8 would just be 7 out of 8. Okay, now there are some basic probability rules that are going to help us out to make things a little bit easier as we go through some more examples. So to list those, first off, for any event A, the probability of A has to be between 0 and 1. Notice that that's less than or equal to and greater than and less than or equal to 1 greater than or equal to 0. So you can still have a probability of 0 and you can still have a probability of 1. So like for 0, that would be what is the probability that you get heads, or tails. So you could get one or the other. Well, you're always going to get heads or tails. That's a probability of 1. But what is the probability of flipping a coin and getting red? Well, a coin's heads and tails. You're not going to ever get a coin that says red on one side. So then your probability of that's going to be 0. Okay, rule number 2. If S is a sample space, then the probability of S equals 1. This means that if you want to find the probability of the entire sample space that something happens, then that's always going to be equal to 1. So if you're rolling a dice, what is the probability that you roll a number between 1 and 6? Well, that's the sample space. You're always going to roll a number between 1 and 6, so the probability of that happening is a 1. All right, rule number 3. This is just the basic definition of what is a probability. So the probability of A is equal to the number of outcomes for A divided by the number of outcomes for your sample. All right, rule number 4 is a very important one, actually. So what is the probability of not A? We call this the complement rule. So that's why in the second parentheses where it says probability of A, it looks like A to the power of C. We read that as probability of A complement. So if you want to find the probability of A not happening, you just take 1 minus the probability that A does happen. Pretty nice, convenient rule, especially when you've got a lot of probabilities floating around out there. All right, number 5. If you want to find the probability of A or B, and notice that there's a different way that you can write this or, that union symbol that we've used previously to talk about domain and range is also a mathematical symbol for or, so you can say probability of A or B. The formula for that is taking probability of A plus the probability of B minus the probability of A intersect B, or A and B. So when you see the union symbol but flipped upside down, that's our mathematical way of saying and. All right, last thing as far as rules go before we look at some examples. So if probability of A and B is equal to 0, then the events A and B are called disjoint. So when you see that word disjoint pop up, that's what it's talking about. Okay, so there's 3 types of probabilities that we're going to look at today. The first of which is theoretical probability. So theoretical probability is the ratio of favorable outcomes to the total number of outcomes. This is a probability that you can find using computation. So when you think about using math to kind of estimate your probability before you do an experiment or something along those lines, that is a theoretical probability. Okay, so to look at our first example of this, when 2 6-sided dice are rolled, there are 36 possible outcomes, which are described in this image to the right. Let's find the probability of each event. So first off, the probability of a sum being equal to 6, which actually can be pretty easy to find if you use the table correctly. The first time that happens is 5 and 1. The second time that happens is 4 and 2. The next time is 3 and 3. And you can actually just go down this diagonal to find all the different places where the probability of rolling a 6 is. So it looks like out of the 36 total, there are 5 out of 36. So the probability of the sum of 6 is equal to 5 out of 36. Okay, so for part B, and it looks like my numbering or lettering was off there, the sum is not a 6. One thing I suppose you could do is count up all of the different places where it's not a 6. But the easier way would be to use the complement rule that we're talking about. So we're going to say probably that sum of 6 complement, or that it's not a 6, is just 1 minus the probability that it is a 6. Which really, if you think about it, if 5 out of the 36 equals 6, then what's left over, the other 31 out of 36, would then not be a 6. Okay. For the last one, for part B here, the sum is less than or equal to 9. You can actually do that a couple of different ways. First off, for 9 in the table, that starts kind of right here. So if you're looking down that diagonal where the sum is 9, that's where that is. If we want less than or equal to 9, we basically have to count up everything below 9. But there's an easier way of doing it. Rather than finding what is the probability that x is less than or equal to 9, let's do the opposite. So let's take the probability that x is greater than 9, and let's just take 1 minus that. So let's again use the complement rule. It's actually going to be quite a bit easier. So if you think about what that is, that it's greater than 9, there's only a total of 1, 2, 3, 4, 5, 6 places where the sum is greater than 9. So if you take 1 minus that 6 out of 36, that tells you that the remaining 30 out of 36 would have to be less than or equal to 9. So you can see that the complement rule is actually a very convenient rule, especially when you're dealing with a lot of probabilities. Okay, the second one we're going to talk about is geometric probabilities. So a probability found by calculating a ratio of two lengths, areas, or volumes is a geometric probability. We're going to focus on area. So let's imagine that you're throwing a dart at the dartboard that is shown. Your dart is equally likely to hit any point inside the square board. So imagine that you're kind of closing your eyes and just throwing it at the board and assuming that you're going to actually hit the board somewhere. So that's the other kind of assumption we'll make. Are you more likely to get 10 points or 0 points? Okay, so first thing we need to do is we need to find the area for the entire square. So the area for our square, notice that it has a label here of 3 inches going halfway across the length of the square. So if you multiply that by 2, that tells you that this entire distance for the square is 6 inches. So then to find the area for your square, take 6 and square it. Tells you that there are 36 inches squared as your total possible area. Then what we just have to do is find the area for both the region with 10 as well as the region with 0. So the area for the inner circle, so the area for where it says 10. Let's think about how you would find that. We're looking for the area of a circle. It tells us that each of these segments is going to be equal to 3 inches. So actually, let's go back. I think I was a little mistaken there. So if those are each 3 inches, then that's 9 inches going across. That means that this really should have been 18 inches total. And then if you take 18 squared, that should have been 324 as your total area for the square. So let's get that fixed. I just noticed that. If you already caught me on that one, nice job. All right. So yeah, now let's look at that area for the 10 points. So there our radius is 3. Remember the formula for area of a circle is to take pi multiplied by r squared. So in this case, that would be pi multiplied by 3 squared, which would be 9 pi. And we'll just leave it as a irrational number for right now, so no need to get decimals just yet. Okay, so then really the only thing we have left to find is the area for 0. And there's really no direct way to calculate the area for 0. So we're going to first kind of have to take our total area, which is 324 inches, minus the area for the largest circle. So that largest circle would have a radius of 9. So that would be pi multiplied by 9 squared. So that would be 324 minus 81 pi. Okay, so now let's go ahead and find what these probabilities are. So the probability that you get 10 points would be the area for 10, which is 9 pi, divided by your total area, which is 324. And now we can go ahead and convert that to a decimal. So if you take 9 multiplied by pi divided by 324, you'll get a probability of 0.087. Whereas the probability of getting is 0, we're going to take 324 minus 81 pi divided by 324. So be careful with how you type that into your calculator. Maybe consider doing it in a couple of different steps. So take 324 minus 81 pi divided by 324 is a probability of 0.215. So which one is more likely? It looks like getting a 0 is more likely than getting a 10, which should kind of make sense intuitively that that would be greater, but we need to show that mathematically as well. Okay, last probability that we're going to look at for today is going to be the idea of experimental probabilities. So in an experimental probability, it's the ratio of the number of successes or favorable outcomes to the total number of trials in a probability experiment. So it's not necessarily what you expect to happen, but what actually did happen. So what you expect to happen is theoretical. What actually happened is the experimental. In fact, some people will call it the actual probability versus the expected probability. So if you see those, just know that that's kind of what they're referring to. All right, so each section of a spinner shown has the same area. So looking at it, you would expect for it to be landing on each of the colors the same amount of times. It was spun 20 times. Table shows the results for the spin results. For which color is the experimental probability of stopping on the color the same as the theoretical probability? So if you think about theoretical probability, you're thinking about spinning it 20 times. There are 4 colors. You expect it to land about 5 times on each color theoretically. So which of these matches that? That would have to be red. All right, that's all I've got for you guys. Have a good rest of your day. And if you got any questions, feel free to let me know.